Here we have to evaluate the given logarithmic expression, that is 4 to the power of 3 positive log base 4 of 2. Okay, so to evaluate this expression, let's consider an important property in logarithm, that is a to the power log x to the base a. Okay, in this expression, the base over here is a, and we have a logarithm at the exponent, and for the logarithm at the exponent, again we have the base a. So whenever we have an expression, that is the base over here is a, and the base of the logarithm of the exponent is also the same, a, then the value of such expression equals to the argument of the logarithm x. So using this property, we can evaluate an expression which is in the form like this. But before we use the property, you have to make sure the base over here and the base of the logarithm of the exponent must be same, so that you'll be able to use this property. Okay, now if I consider the stuff we have in the problem, that is the expression we have in the problem. So the base over here is 4, and we have a logarithm at the exponent, and for that logarithm also we have the same base 4. Okay, so but can we use this property over here? No, we cannot, because here at the exponent we just have only one logarithm. But in our expression, apart from the logarithm, we have a value 3 added to the logarithm. So we have to get rid of this 3, and we must have only logarithm at the exponent. So how do we have to get rid of this 3? So for that, what I'm going to do is I'm going to consider this 3 as 3 times 1 positive log 2 to the base 4. Now 4 to the power of 3 times. So instead of this one, I am writing log 4 to the base 4. Because in a logarithm, whenever the argument and base are equal, then the value of such logarithm is 1. So in the value of this log 4 to the base 4 is 1. So instead of 1, we can write this log 4 to the base 4. Why do we have to write this log 4 to the base 4 instead of this one? Because to simplify with this log to the base 4, I am writing this one in terms of logarithm. That is log 4 to the base 4, positive log 2 to the base 4. Okay, 4 to the power of, okay, now I'm going to use a power rule of logarithm. So whenever there is a number multiplied in front of the logarithm, the number can be taken as the exponent of the argument. So this is called a power rule of logarithm. Then in the next step, we'll have log 4 to the third power to the base 4, positive log 2 to the base 4. Okay, let me continue over here. 4 to the power of log, and evaluation of this 4 cube is 64, log 64 to the base 4. Positive log 2 to the base 4. Okay, now at the exponent we have addition of two logarithms with the same base 4. So we can use the product rule of logarithms. So whenever two logarithms are in addition with the same base, what we can do is we can write logarithm once with the base what we have for the two logarithms, and we have to multiply the arguments 64 times 2. Okay, here I am able to simplify the addition of these two logarithms because we have the same base. So that's why instead of this one, I am writing log 4 to the base 4, so that I can simplify this logarithm with this one. So that because we must have the same base, so that we can add two logarithms and we can simplify. So instead of 1, even we can write log 3 to the base 3 over here, or log 5 to the base 5 over here. But specifically, I am writing log 4 to the base 4. The reason is for the second logarithm, I have base 4. So for the first logarithm that I am going to write instead of 1, also must have base 4, so that I can simplify. Okay, now let's proceed further. Okay, 4 to the power of log. Okay, when I multiply the 64 and 2, I'm getting 128 to the base 4. Okay, here look at this one. The simplified expression over here is exactly in this form. So the base over here is 4, and the base of the logarithm at the exponent is also the same 4. Then what is the value of this expression? It is equal to the argument of the logarithm over here, that is 128. So the evaluation of the given expression equals to 128.